Okay, let's go and get started if we could. How's everybody doing tonight? Everybody get the pen in, you're into Eagle. I'll go ahead and put that on the board real quick. Okay, up front, before we get into the class stuff, I wanted to mention a meets on a rooftop once a month, a rooftop apartment, and then they meet at the local Apple store there in Michigan Avenue. We don't have a local Apple store. The closest one we have is in Schaumburg, and that's the actual group that's going to be supporting this is the Schaumburg Mall Apple store. All right, well, let's go and get for week 3. We'll be going over tonight protecting systems and review questions and quiz as always for the chapter 3. The lab for week 3 I put up on the whiteboard. We'll be doing a snort lab, and not the drug type, and we'll be snorting packets on the network and peaks in traffic using a couple applications, actually two applications we'll be using. And so we'll see the traffic or the data actually travel across the network and be able to capture that data in real time and talk about the importance of network admins being able to do that to determine network traffic, IP traffic, UDP traffic. We'll talk about all those protocols. And then also maybe how hackers can use this type of tool or these type of tools to thwart the network and to try to do malicious activity. And so we'll be doing that on Thursday. You will be downloading software on the computer. So if you have your USB drive, you can just download it onto that the night of the lab. And you'll also have a handout as well. So when we get into network security, we've talked about this already a little bit. No network can be 100% safe, but there are things you can do to safeguard your network from attacks, from internal and external both. Actually, the number one way networks are attacked today worldwide are internal, not external. Most people think it would be external. I'm not saying it doesn't happen, but disgruntled employees are the number one reason internal. Also, folks being able to see items they don't need to see and being bored and doing something they shouldn't be doing. My philosophy in network security has always been to have kind of an out of sight, out of mind for users to where you're not making their job any harder by what you're blocking or not blocking or not letting them see or letting them see. Because the more that they are not impeded by the network department, the better they can get their jobs done. And so we'll talk more about that this semester, but that's been my philosophy for the years. So there are different ways to secure your network. Many of you probably know about software-based through antivirus probably and firewall softwares. There's hardware-based protection through routers and switches, and then perimeter protection through doors and access to server rooms and computers and any type of computer hardware you might have on your premises. And so we're going to look at what's called hardening systems tonight and list different ways you can do it. We'll talk a little bit about SQL injection, which is used a lot on web servers to bypass admin authentication and how to protect against it. And then look at some protect systems that help communication-based attacks and various software applications that there is around. So hardening an operating system basically is taking your existing operating system and making it to where it's as difficult as it can be to come in and have someone do a malware attack or a virus attack or whatever. There's a three-prong approach to hardening a system. One is managing updates. It does not mean apply all updates. Managing is different than installing updates. Managing means testing every single iteration of updates on a test machine in your environment before rolling it out. If you try to just roll out updates nilly-willy on a network, it can really cause a lot of damage. It could disable software, it could disable services, and folks could show up in the morning and not be able to do their work, and you'd be in the unemployment line. Okay? And so managing updates is critical when it comes to network security. There are some that have philosophy in networking security to apply all updates. I'm not one of those. You'll find a lot in the network security field that feel the same. If any of you have ever had an update on a computer that has maybe caused havoc, whether it be on printing, whether it be on hardware, whether it be on software, you know what I'm talking about. And so updates is definitely critical, but it needs to be managed. And the way I always have done it is have a separate system on your network that's totally off the grid, to where you can install these updates, test them out before rolling it out to the entire organization. Protecting against buffer overflows is a second. And then thirdly, configuring operating system protections internally. So managing updates, update terminology, some of you might know this already, but the task of writing a secure operating system is daunting because you've got so many entities connecting to it, not just your software that they're writing, whether it be for Windows, whether it be for Linux or Mac OS we're talking about. You have third-party vendors that are constantly writing applications, but you cannot give them control to your system core for security purposes. You cannot give them control to system access to the OS for security reasons. And so some of these softwares will actually create headaches for an OS. Also, I've seen hardwares as well. So if you have say an old scanner connected to a printer or to a network as a network scanner, and you update software on your network and note that driver that's for that scanner no longer works. That's an example. Because generally when you get updates from an OS, you also have in those updates two types. One is critical updates, the other is vendor updates, meaning HP, Microsoft, IBM, to name just three. These are vendor-specific updates that operating systems will update their entire operating system to meet the needs of these vendors. And why do you think they do that?
Keep their business.
Yeah, these are the largest entity where they make their money. Not that they don't make money off consumers, but they make tons more money off corporate. And so reading the updates line by line is very tedious, and nobody likes to do it. But probably 3/4 of the updates that come on a daily basis are vendor-specific updates for a certain hardware that's been added. Somebody created, say HP created a new scanner, a new printer. Well, if you don't have those devices on your network, you don't need to update that patch. You don't need to update. Now, due to the increasing length and complexity of operating systems, there is unintentional vulnerabilities that are introduced by and can be exploited by attackers. An example would be this. Say a network has not been updated, network operating system has not been updated in 5 years. The same holes that were there 5 years are still there in the 5-year time span. Hackers know that, and they know probably 50% of businesses in the US are 5 years or more behind in their updates. And that's probably a conservative number. So what that means is the reason we're getting all of these iterations of attacks and malware and viruses over and over again, partly is because of the spread, the culture spread of that is because the corporate environment does not have a secure network in general. They don't want to create updates. They don't want to apply updates. They don't want to take the time. So what they've done is this. What I just mentioned to you about updates can probably scare some people and then not doing updates. And that's what's happened. Instead of managing updates, like I just mentioned, how I do it, they just don't do updates at all. And so because of that, you've got multiple critical updates out there. And these same viruses that actually have patches now and fixes since they came out are still alive and vibrant in 50% of businesses today. and they just keep perpetuating themselves over and over and over and over and over again. The antivirus companies love it. Even the OS companies love it because it keeps them, the programmers anyway, side of it in business and making things more secure. But you cannot force a business to apply an update. But I think the problem is that the businesses, well, I know the problem is the businesses don't take the time to manage those updates, and so they get attacks over and over. So here is a screenshot of some different types of OSs and the lines of code it took to build these OSs. So we start at the top with Linux, 5 million. FreeBSD, which is an offshoot of Linux, 9 million. Red Hat, Linux, 30 million. Mac, 86 million. Debian, 238 million lines of code. Microsoft will not give out their lines of code to anyone. Now internally you can find that out, but it's not going to be published pretty much anywhere that I've seen. Microsoft is pretty leery about their release of things because actually if you think about it, Microsoft is the #1 target for hackers. All these OSs I just mentioned up here on the overhead that's in your book are the least susceptible OSs to be attacked by viruses. In fact, I can tell you all of these generally don't even have an antivirus software running on the system, if that tells you anything. From server level down to client level. And the reason for that is there's very few viruses out to attack these. Not that there's some out there, but there's very few. The hackers' main target for NOSes is Windows. It always has been. Yes?
Do you think in the future that there'll be more people targeting Macs because
No.
more people are starting to have them?
Nope.
No?
Mm-mm. No, and a couple of the reasons for that is the culture of OSs, the culture of OSs, Microsoft culture versus Mac versus Linux. Mac and Linux is based in an open source consortium for programmers, meaning anyone can submit changes to the code, and some of those changes do get into the new versions of the operating system with Mac, Linux, all these that I mentioned up here. Windows does not do that. There is no outside contributors to Windows OS. You can submit bugs, you can tell them what's going on, but they're not going to, openly bring in someone's code or even act like they want to look at your code. And so it's kind of a culture of, the only way I could put it is snootiness on the Microsoft side, where they do not integrate developers. Now what they do offer, though, that I do like, Microsoft does, is they do offer to students their software at no cost to learn the package and then go out into businesses and build the packages for the internal companies. And that's a positive thing, I think, personally. But what they don't think of is this. Those same developers that are learning this in school go out, some of them do out into businesses to productively build apps, but a fraction of them go out and use that same knowledge they learned in school and with that free software that Microsoft gave them to become hackers for the OS that they have the IDE interface to create code for, if that makes sense. And so the only difference, and the reason I say it's never going to happen in these probably to the extent that we see in Windows, not to say there's not viruses in these areas that are prone, or that people create viruses for, but they're very, very, very slim compared to, probably 1,000,000 to 1, I would say. That's probably being very conservative in that estimate. But we've seen attacks on not just Windows OSs, but Windows mobile devices. There's viruses out there from Windows mobile devices as well. And they have antivirus for both mobile and client-based. I am a full-time Windows developer during the day, and so the reason I know what I'm talking about is because this is what I've done for the last 20 years as far as software development. And I've hung around software developers for Windows, software developers for Linux, and the difference is the mindset of open source. Hackers love open source because they can develop tools, and if you notice, if you do it, well, even the class here, most of the tools we use in here for network security, even in Cisco, is a Linux-based tool. Well, who built those tools originally? Okay, think about it. Who originally built these tools or thought of these tools, and what was the purpose of these tools? Now, a lot of these tools are definitely used in businesses. We'll use them this semester. But the original intent for some of these apps, sadly, say, was malicious intent. An example would be a program we'll use this semester called Cain Enable. It also has a Linux base and a Mac base and a Windows Linux based, Mac based, and Windows based app, both, all three. But yeah, the culture of hackers is to bring the man down. The man is not Mac. The man is not Linux. The man is Microsoft. And that's just the way it is. And a lot of it has to do with, if I'm a programmer, which I am, and I try to submit to Microsoft an issue, which hackers do this a lot, by the way. Submit an issue, a virus, a bug, or whatever malware maybe that's embedded in the system code which they found before. Microsoft will sit on it, purposely sit on it, or say there's no problem with this, or we haven't seen this issue before. And the reason they're doing that, rightly so, is, if you were Microsoft, is I don't want to tell the world this issue's happening, even though the whole blogosphere is saying it's happening, right? We've all seen it when new OSs roll out. People complain about this feature, that feature not working, this feature not working, that feature not working. I mean, the list goes on and on, right? But why does it still flourish? The reason it still flourishes is the number one software for businesses today is Windows. Number one still for businesses. Now that's changing a little bit in the last couple of years because of iPads and because of mobile. But still the number one software, an example would be Windows Office platform. That's used in probably 80% of companies worldwide. Just that one software alone. And it only runs full spectrum on a Windows platform. They do make a Mac version, but it's always about 2 versions back. They purposely don't only update it to be 2 versions back. In the graphics world, which I was in before becoming a teacher, most graphics departments like printers, newspapers, magazines were Mac clients. But most businesses, sales, have traditionally been Windows. But we have seen a shift because you will see a lot of businesses actually thinking about shifting to a tablet device. And the options they have right now, a viable option is the iOS device, the iPad, or the new Windows 8 devices. We had RT, and then now we have Professional coming out where you're supposed to be able to save to the hard drive, use USB ports, things of that nature. But the apps that if you've not noticed, the apps on Windows 8 mimic closely the apps and even the App Store from the Apple environment. A lot of the coders and programmers that Apple's hired over the last year and a half are developers or ex-developers from the Apple world and Linux world. So with that shift, though, I think it will help Microsoft, but every month the increase of viruses heavily increases. In fact, within days after Windows 8 was released, there was about 1,500 viruses already created specifically for the Windows 8 OS platform. And a lot of these hacker consortiums, they have white hat and black hat. The white hat are those who say, okay, I'm going to give you 30 days to fix this, patch it, whatever, and we can even help you, and here's what we found. They give them all their code and everything they found. If they don't do it in 30 days, they create another group that goes out and begins to attack it with viruses and malware on purpose. And so that's where the whole struggle is, I guess, between hackers. And you could say, they've got, and in some senses, you say, well, that's a pretty good deal that they do that for Microsoft. Why doesn't Microsoft respond quicker? And the reason they don't is because of culture. They don't want to look like, yes, they're accepting all this from the hacker world, to help them with their code. So that's the reason why. Long answer, I know. But yeah, the viruses in every Mac conference I've been to, it's funny. With the Mac reps coming up and they're doing a demo or whatever, I've asked all of them, about antivirus because I know there's a few out there. None of them have antivirus on any of their machines. No, even though you can buy antivirus for a Mac platform, none of the sales reps, none of the engineers that develop hardware for Apple have any antivirus whatsoever on their machines. And what's even funnier is in a last Windows conference I went to with the new, I think it was Windows 7 when it was rolling out, behind the counter they were actually demoing, I think it was Windows 7, but behind the counter it was running on a Mac Mini. The Windows 7 environment was, and I was kind of talking to the rep and I said, what's going on there? And he goes, well, it runs better on the Mac OS Mini on the Mac Mini hardware than it does on our hardware. I'm like, really? He's like, yeah. And so, because it's, the Mac platform now is Intel, so you can install Windows natively on those devices, and so you can dual boot and everything. Windows is getting better, but the tablet was a telltale sign to me that Windows wants to change. They have to change. It's not going to be here in 20, 30, 40, 50 years or whatever. It's going to be a lot less saturation in the market for sure. So I think the Windows 8 platform and the tablet specifically was a good move. Personally, I think it was. And the app development for developers is if you're an iOS developer already, which I'm a developer in iOS platform as well, the Windows 8 developing platform is pretty much straight across the same as iOS platform as far as how you create it, how you deploy it. The App Store now that Microsoft has for their mobile devices, it's all pretty much the same now. So that'll help developers for sure. Will it help virus companies or will Windows be less and less infiltrated viruses? Probably not. That's going to keep happening. But good question. Now here goes into, I think 2007 was the latest release we have of Windows. I don't know what it is for 7 or 8. And again, these could just be numbers they throw out there for you. It could be the same for the Linux guys too. But MS-DOS was the very first platform of operating system. Some of you, well, most of you in here don't ever remember that. 1981, I was I was 8th grade. I was in 8th grade in 1981. 4,000 lines of code. And in 93, the first GUI click interface NT version 3.1 came out. 6 million lines of code. All the way up to present day Vista, 50 million lines of code. Again, you'll notice the iteration is pretty like 10 million, 20 million. So it could be just a number they're throwing out more than likely. But there's a lot of lines of code for sure, definitely. And so what's the matter about lines of code? Lines of code means over the years of iteration of code, there's been literally hundreds of thousands of developers. Some have worked for Microsoft, now they're in the Linux world. Some worked for Linux, now they're in Microsoft. And so this source code, over the years, has definitely gotten in the hands of people probably it shouldn't have gotten in the hands of, and then be able to develop viruses from that knowledge. Does that make sense? And be able to figure out reverse engineering, which is a term in software development, where you can take any application, reverse engineer it, and find out the code that application was built upon, and then be able to go in and hack that code to do what you want to do, to go in and backdoor that code or do some malicious intent to that code. All right? And we've seen that happen with viruses. That's how they do it. They go in, reverse engineer a certain segment of Apple's code, create an app that does go in and be able to maybe remote control a computer easily, be able to listen to the keyboard commands that a user types in silently and email it to a hacker, being able to take screenshots every few milliseconds and sending those screenshots to a hacker when it sees a secure session on a web browser. So those are just a couple things that virus do and malware does. So I've already talked a little bit about security patches, just some terminologies the book goes over in security patches, or patches in general. One is security patch. These are ones I talked about earlier, that the 5-year thing where companies are 50% of companies are 5 years behind, and security patches. Security patches are patches that literally are designed to patch holes in the OS lines of code that specifically have been pointed out to them from either hackers, from internal testing, or customers, and those are fixes for these. And those should be applied. Again, they should be applied in a test environment first before being rolled out, but they definitely need to be updated on a regular basis. Hotfix is specifically for customer. I talked about this already, vendor specific. If you go look in when you get home tonight, look in your control panel and your Windows software. In fact, now, I think since Windows XP, there's actually a checkbox now that says, it basically by default does not show you the updates anymore. You have to check a checkbox that says, show me the updates, which is hundreds of them, if not thousands. But notice, if you would, we won't show you tonight as we go through this, but go home and see how many hot fixes are actually applied on a daily basis. And I mean daily basis. Sometimes twice a day, Microsoft will have hot fixes. Service Pack is a cumulative of everything above, all security patches plus additional features. Hot fixes sometimes do not make it into security patches or into the cumulative service pack, but definitely the additional features. Service packs are generally okay to install, by the way, in my experience. It's a trimmed down version, a very clean version of updates. What they do with service pack is they say, okay, over the last year, we've released, say, we'll just put a number out there, 1 million updates in the last year. Out of these 1 million updates, 300 of these have given customers no issues whatsoever. That's going to be our cumulative service package. Okay? That makes sense? And so that's how they do cumulative service patches. And cumulative service patches are generally quite large in size. You can get Microsoft to send you a CD or DVD with the content. And so these are fairly safe to install, in my estimation and my experience, because they do not have a lot of hot fixes in them, or very few. And those that they do have, customers have had no issues in the last year with those hot fixes. Because believe you me, customers do complain when they apply a fix, whether it be a security patch or a hot fix, and it causes problems. Because it gives that company lost revenue, and Microsoft has been sued millions of times, probably, literally, since they've created the company, just like Apple has too, I'm sure. And we don't hear about that, but on a daily basis, these companies are sued by somebody. When you're that large, you're going to cause problems somewhere, okay? And somebody's going to complain, and you're going to get a lawsuit. So it's got some features here. I'll just run through real quick. I won't read the description on all these, because you probably know some of these already. But critical update, these are fixes that generally solve a problem that a feature does not function. So for instance, example would be, a critical one would be, bookmarks do not work in Internet Explorer. I'm just throwing one out there. Can't create it. Doesn't work. That would be critical. Network connection is dropping sporadically on all customers with this newest Windows version. That's a critical update. Okay? Feature pack, these are things that are just a lot of times fluffy stuff and graphical bloatware that basically just takes up your system space and graphical, and they look nice, but one of the features when 7 came out, no, it's XP actually, when it was in the beta stage, was they had the ability to play a movie in the background of your desktop instead of like, the static images we have, a movie all the time blooping in the background of your desktop. Who wants that? Who needs that? Maybe somebody wants that, but who needs that? I guess somebody did want that or they wouldn't have created it. But, I mean, literally you could see your processing power just go from here down as it was running. It was just crazy. But that would be a feature pack, okay? Update, fixing for all users is specific non-critical. Updates generally don't have a security threat. A patch, Broadly released for security. These are generally needed to be updated on a managed basis. Hotfix, a single cumulative patch that addresses a vendor-specific situation. Update rollout, cumulative of hotfixes, security updates, critical updates, and updates. Now this one's one you want to definitely stay away from is the update roll-up. That one you want to stay away from because they package all of the fixes or hotfixes, which are vendor-specific, security updates, that's okay to have in there, all into one, and that I've seen cause a lot of problems with networks, for sure. Then the last is service pack. Again, these are cumulative, and it's not when you say cumulative, the word cumulative does not mean totally 100% of everything. Cumulative is a percentage of something. Now it's looking at the whole, but giving only a percentage. So an example would be a cumulative final exam of the last 14 chapters, but of those 14 chapters, we're only going to take out 5 questions of each chapter. Okay, that's not total, that's just cumulative. So that's what it's saying is, you had 1 million updates, we might now have only 300,000 that's in this cumulative that customers heard about. I've already talked about patch management, I won't talk about that anymore. You just want to make sure that you test it on some separate environment. It could be, as I mentioned last week, a virtual environment. You install a machine with virtual PC. On that virtual PC has this exact image that you have on every single computer in your network. Same software, all the software that could ever be installed, all the applications, settings, everything, drivers, connection to printers, scanners, hardware, and then you test it on those machines, and if it doesn't work, it's only going to affect that machine, and you can roll it back. And if it's actually on a virtual image, I never roll it back. I delete the virtual image and get a copy of it that I backed up and start all over again. Because sometimes backing up these packages are nearly impossible to do and to undo these patches. Another thing too, if you haven't noticed, if you've ever done updates before on a server, when you do an update on a server and it restarts, it does not automatically restart all of your services that you should have started for your server to work, your company to work functional. Because some services are manual in starting, some are automatic. But I have seen some of these patches actually turn off multiple startup services that were set to automatic. They set them back to manual, so they didn't start. And about midday, or usually not by that, by 9 a.m., somebody's screaming about something not working. It's some type of service that was not started up. And so you could also have a test server, which I've done before too, in these larger patches, where you make sure that on these test servers that the services all start up. And if they don't start up, make note of what does not start up automatically to where you can go back in after the update on the real server, the production server, and fix those services that were not automatically checked again. Does that make sense? And that happens a lot of times too, by the way. A lot of times that happens with Microsoft updates. Now with normal consumer computers, you guys don't really see it because you don't have a lot of services that you're depending upon every day to do something. But some of these third-party apps that are installed on servers have their own unique services. It's not Microsoft services, it's their services. Microsoft doesn't even know about that service. Okay? It's a third-party app you bought for the company. So when you apply the update, it disables all non-Microsoft, some of these updates disable all non-Microsoft services and then re-enables them as a manual process, a manual start, which can cause a lot of havoc. So patches just need to test is all you need to do. This is one thing too you definitely don't want to do right here. On any machine, whether it be your home computer, work computer, server, you do not want to check this one here where it says install, download and install updates automatically. Don't ever do that. The one I recommend is you can download updates, but let me install whether to install them. And also there is software that you can buy and even create yourself that blocks users from getting to this screen on their computer whatsoever, to where they can't get to it. You can go into group policy editor and block this from being accessed. You can even block Microsoft's update website, which I've done before, easily, and I recommend that as well. where folks can't even manually go to the updated website where they download stuff to get to it. It doesn't let them get to it. It just totally doesn't let them get to it. So definitely that. Overhead, my thoughts on that. So let's look at the automated patch updating scenario. You've got Microsoft up there downloading on a nightly basis at 3 a.m. in the morning, your patches. Then the automated patch server distributes it throughout the system. This automated patch server is a managed patch server that you can tell what patches you want to go and what you don't want to go. All right. A lot of these patch servers will also let you install any application, and when people are not logged into their computer, it'll literally log into that computer, install an application, open the application, shut down the application, restart the computer. It'll do all that on all corporate machines if it's set up correctly. You can take, say, 10 software packages you want installed in the next month and manage when you want them installed with this type of management package. And there's them out there, by the way. Buffer overflow is basically a process that attempts to store data in a random access memory, or RAM, beyond the physical boundaries of that RAM. Extra data overflows into the adjacent memory locations, and under certain conditions can cause the computer to stop functioning. Attackers use buffer overflow to compromise the computer. Here's what they do. Okay? Buffer overflow is used in software development from a hacker standpoint to interject software to bypass preferences, properties, and authentication. It's where you can basically bypass key entries of serial numbers, bypass features, actually turn on features that everybody else can't even see. Because when you reverse engineer a software, you can see sometimes in the code areas that the developer decided not to turn on right now, but it's in the code still, it's commented out maybe, or disabled from running. Well, if you reverse engineer software, you can actually turn on features that the normal consumer doesn't even see. And there was actually one of the versions of Windows a while back that in beta stage that was out and about in the hacker world that had turned on a whole bunch of features, like 150 features, that was not out even in the beta stage for people to look at, but they figured out how to reverse engineer and turn all these features on, and they were loving it. They were just having a good old time, and they were submitting bugs on features that no one should have access to but Microsoft. And Microsoft was like, we don't have that feature turned on. The hackers go, we do. Well, why? Can you guys fix it? I'm like, no, you're not supposed to have that feature turned on. We turned it off. Not, you know. And so it was kind of funny that the hackers actually purposely did this right. Then they contacted Microsoft and wanted to fix something that they shouldn't have been able to get into anyway. And when Microsoft said what I just told you, they said, well, we've already created a fix. We'll send it to you. Make sure to see if you can maybe implement it before you release it, you know, whenever that is. And believe me, they get tons of this. And Microsoft hires quite a few ex-hackers, as you can imagine, because it's a cush job, actually, if you think about it. You know, you're 20 years old, 22 years old, and they find you have these skills, you've submitted some stuff. They have actually approached kids on campus that are doing this and say, we want to hire you. And they give them all the Mountain Dew they can drink. They give them a cubicle, a nice apartment with an expense pay, per diem, and they're sitting pretty, you know. And they hack all night long on the OS to figure out bugs and issues and fix it. So, you know, it's kind of that old saying, you know, keep your enemies close, keep your friends close, but your enemies closer. They definitely do a lot of that. So basically what buffer overflow does, I've already mentioned a little bit, but in layman's terms, it just overflows memory to do something like malware, to interject, to bypass a key, for a registration process, or for turning on a feature, turning off a feature. So malware, the program jumps to the attacker malware, and then the software that's reverse engineered can then do malicious activity with that software, or just get into that software to use it. If you don't know anything I'm talking about, just believe me, okay? But there is tons of peer-to-peer software sites where you can download any software that's created today, from Windows OS to Mac OS to Linux. You don't have to because it's free. But I don't know if you noticed the last Microsoft update, the last Microsoft version update to 8, I think it was only like $40. I think that's what I paid for it, for Windows 8 to do the update. Now, granted, you didn't get the DVD, but that's the cheapest yet as far as an update of an OS. And the only, I think Apple's always runs around $30, something like that, for its new version. And Apple generally never has a security key to type in. You don't have to type in any key with Apple's updates or their CDs or DVDs. They've never had any type of key to enter in like you do with the Windows environment. They've never had that. That also stops them from being hacked. It's a cultural, mental thing. Okay. Now that doesn't say people don't download illegally Mac OS software, because they do. But if you look at it compared to how many downloads Windows OS software legally compared to Mac OS software legally, it's going to be quite a bit different in that number. And it's just, again, it's a mentality type thing. Apple knows if we make people type in a code, the hackers are going to get PO'd at us. And they're going to start hacking our machines. They're going to start hacking our OS. Because we're not trusting people. It's all about trust. And so the whole idea, and we've all been there in the Microsoft world, where you maybe installed Microsoft OS on 2 machines, maybe one pooped out, you had to install on another one, and you had to call Microsoft. Push the numbers. Oh, it's just easier to download it from a peer-to-peer. Right? That's why people do it. All right? Do all people that download illegal software, maybe do it on, just on a whim? No, it's because of frustration, some of them. I'm not saying it's right, I'm just saying that's a fact of reality. And so, because of that, software is a big market, as you can guess, and security of software is big as well. And viruses are created every day against the man. And the man is, as you already mentioned, Microsoft. And he'll tell you that. Bill Gates will tell you that. He knows he is. And I like Bill Gates. He's a cool guy. Made a lot of money. Data execution prevention, DEP. What this means is in software, they do have, and in fact, starting with Windows 7, Windows Vista actually, basically allow software developers to enable hardware protection specifically for application software that they develop. What that means is you can, for the first time, create an application, dump it in a folder, and run it without being registered, without applying a registration key in Windows. You just run it. That type of philosophy is on a philosophy called kerneling software. Like Linux has had that for years, and so has Microsoft, so has Mac. And everybody's heard of the .NET framework, probably, right? Make sure you got the right version of the .NET framework. The .NET framework basically is a separate OS in and of itself. It's a separate operating. It's an operating system built within an operating system to allow this, what I've talked about right up here on the screen, which is the no execution or no ties to basically registry on the machine. And that's the prevention right there. Help prevent damage from viruses and other security. Turn on depth for all programs except for those I select. And the ones if you were to turn this on, the ones you would add to this would be custom software you've developed on Microsoft's machines. But again, most businesses have this feature turned on maybe just for the essential Windows program services only, and that's it. If they have that, because you can turn that feature all the way off as well. Okay, I want to get to configuring your OS for security protection. first thing you've got to have within most organizations, they do have some type of security protocol. It might be quasi in nature, meaning it's not fully formed and it's just verbal. Then you have a configuration baseline that every machine is going to have this type of setup, security template, and deployment. So when a new user comes in, they have this image in IT somewhere in a server that immediately is deployed to a new machine or even an old machine with this image. The user logs in and they have the same image the guy next to him has. And what I mean by image, those of you who aren't familiar with that term in computers, it's just one file that is compressed of all of the files in your hard drive. And you can set up these computers to turn on and boot up and grab one file and update all these computers within a couple hours with one image. And have the same software, application settings. Because what you generally do is you take one computer, set it up with your OS, your programs, your settings. You create an image from that one computer, and then you turn on these computers with either a USB thumb drive that boots from a USB thumb drive, or you can boot it from a NIC card now with newer NIC cards to go out to a certain network path, and in that network path it starts a program that restores images or creates, or for the first time brings an image in. And so very easy to do. And Windows XP 7 and Vista have a pretty good built-in versioning software, imaging software built into the OS. If you've never used it, it works pretty well. You don't have to buy third-party. A real popular one that used to be around was Norton Ghost, but no longer do you have to, because Windows now has its own built-in imaging software where you can save the entire contents of a hard drive onto one file, back it up to DVDs, plural, or an external hard drive, and then when it crashes, which they will, you can restore it. Okay? All Windows machines crash. Microsoft will tell you that. They do. Some more than others, depending on what sites they go to and how many viruses they have. But preventing attacks that target the web browser, attacks on web browsers can comprise of cookies, JavaScript, Java, ActiveX, and cross-site scripting. You might have heard of JavaScript, I'm guessing, and Java, ActiveX, maybe some of you, and cookies. Cross-site scripting might be a new one maybe for some of you. And all that means is you are taking a web page that say was developed in PHP, and a hacker can come in, know PHP code, and be able to go into a web page, any web page, be able to figure out how that website's built on PHP, and then do a cross-site scripting reverse, kind of like a reverse engineering of a website to bypass logins. So regardless what the login is, it can bypass it altogether to get into a screen or screens. And a lot of your corporate environments actually have remote screens, like web login interfaces, that there are some ways to get to it. It might not be a direct URL, it might be an IP address, but hackers find that IP address, then they can get into that site using a cross-scripting attack. Cookies, I'm not going to mention this because really they're not a big issue when it comes to security in my mind, because every web browser has to have cookies turned on to go to any website. So that's not, in my mind, I've never seen any issues with cookies. It does collect your data as far as pages you visited, at what time you visited, how long you stayed on the page, things of that nature. JavaScript, this one can cause some issues on a website. It can do malicious things. It can have a pop-up that says OK on the button, but you click OK and it installs an ActiveX component. And that ActiveX component might be a keylog program that begins capturing your keyboard commands and sending them to an email address, for an example. JavaScript can do all that and launch all that. But you do have to have a button first that says, do you want to continue or something like that? People say, okay, they hit okay, but instead of continuing, it launches an application. And that's the way the security is bypassed on Windows. Scripting language, I already mentioned a couple, or PHP being one, ASP.NET's another, where folks can go in, hackers can go in and visit a website and create malicious activity on that website or bring the website down totally. JavaScript runs on a user's computer. PHP and ASP runs on the server itself. Defenses on JavaScript is within the browser you can set certain things from not happening, like not allowing JavaScript to allow executable code to be ran behind the scenes without the user's consent. You can block those type of scripts altogether as well within the Windows IE setting. But I mentioned IE setting, that means it only applies to browser-specific components. And most businesses still do use IE, but real fastly approaching in businesses is Firefox and Chrome. Those two browsers are very much approaching saturation in the market, especially with Chrome. They're like gangbusters every day, new updates, new security updates. If you notice, Chrome's really focusing on security right now. Like every other day they have a security update. They want to get the business market, for sure. And that's the only thing missing. They have to get that fixed in order to get in the business realm, because they won't use it. Businesses won't use it. And there are some apps in businesses that are specific designed to use IE. It will not use any other browser. Will not use. It won't work. Won't work. And so Microsoft knows that, and they like that, and it's good for Microsoft. But there are other ones coming up. Chrome would be one, I would think. That's definitely one that's coming up. It's a good browser, and it does have, though, Chrome is actually built on JavaScript as its backbone for the OS or for the app. And JavaScript is an issue in Chrome, meaning you can do a lot of things in Chrome with JavaScript that users don't know about in a website. Chrome, if you haven't used it, you do all the commands in Chrome in the URL, all the setting commands. If you know what you're doing, you can actually go in the URL of a Chrome browser and set any setting you want to, both development settings. You can, like, say, turn on a camera to where when you go to a certain web page, it turns on the camera of that computer without the user's knowledge and begins recording. That's a development feature. That might be a red flag to some businesses, maybe. It's kind of cool, though, I think, personally. But, a lot of cool stuff they have, a lot of cutting edge stuff they have, but definitely more towards, it's definitely geared more towards consumers right now, but they are heavily seeing that used in businesses. Most IT departments still will not deploy anything but IE because of security and for good reason. And so you're not going to see Chrome and Firefox being saturated in businesses anytime soon. And if you're an IT person, you more than likely in your place of business don't allow that to be the default de facto browser. It's usually IE because of security reasons, as I mentioned. Java's the other one. Java does allow you to run apps. It's a standalone application, Java is, and it's a separate app that runs off a web server, downloaded onto the computer, and can be hostile because once it's downloaded on the computer, it then becomes a trusted app to do whatever it is that app wants to do on the machine. So you can, within IE, again, block Java, but it is unblocked by default in most other browsers. It's blocked somewhat, but not blocked like it is IE. And so that's why you see a lot of businesses still using IE for this very reason. So Java basically, as I mentioned, downloads to the user's computer. Then it gets to do whatever it is that it wants to do once it's downloaded. Sandbox is a feature within Java that can capture something and put it in a Java sandbox to not hurt anything on the machine. So here's an example of a Java form that looks like it's a login form. And warning, you'll notice here at the bottom, it says it's a Java applet, meaning anything you do, when you click that login button, it can do anything that app wants to do and been developed to do. And it might not be just logging into a web page, possibly. So that's a red flag. And then lastly, I'll mention tonight ActiveX. ActiveX is a component built originally by Microsoft, and what it was is it's not a programming language, it's a set of rules to do certain functions, and basically it's automated functions that can be performed in a certain order. Okay, so an applet could do, an ActiveX control could say start up Windows Media Player and play this video. Start up Windows Excel and Microsoft Excel and read this file. It can also do other things maliciously as well. If you know how to code it, it can do things behind the scenes like delete the folders in the C drive. Delete some folders, delete system folders, whatever. It can do that. If it's trusted, which it is because it's a Microsoft product. And so inside of Windows Office now, they actually have, and it's been this way since Office has been around, you can actually code any Office application with a programming language called VBA, which allows you behind the scenes to program buttons, forms, interaction, whatever. If you have those type of components called macros or ActiveX controls built into a document, and you give it to somebody that has Windows Office as well, it'll tell that user, oh, by the way, this person has an ActiveX control on this. Do you want to activate it? Well, most people say okay because they don't know any better. But when they click OK, behind the scenes, it can do anything it wants to do because it's literally a program built into a document. So it could be an Excel document, a Word document, whatever. And then that program can do whatever. It can delete files, it can install programs, it can go to websites, download files from websites, email documents, do whatever it is that it's been programmed to do. So I always tell students and to tell people that never open a document that says this document has an ActiveX component. Do you want to run it? Say my default is always no. I do not want to run it. Then I'll contact the person by phone or whatever and say, hey, by the way, I got this prompt on this. Do you have some special component? And a lot of times they'll say, no, I didn't put anything in there. And they don't even know it because malware can attach itself to documents like Word, Excel, PowerPoint, and the user that it attaches it to, that machine, does not prompt them at all. Now when they send it to somebody, that's when it gets the prompt because it's in another machine now. And so these are still around, by the way, even with newer versions of Office, they're still around. Okay, because you can still, anybody that knows what to do can actually go into Tools menu in any Office application and go VBA, and you have pop up to you a code window where you can begin developing code and forms and functions and procedures to run for that application, for that document when it's opened up. Does have a security concern. Windows IE does have blocks for ActiveX by default. The newest versions of 9, I believe, is out, and 10 has blocked ActiveX execution without the user's knowledge. But again, Chrome does not, Firefox does not. So that's why you see these browsers not used on a business environment because of that. Even though I love both browsers, don't get me wrong, I use them a lot myself. But it's not ready for business. It's not ready for rollout in business because of just these last few slides. ActiveX, JavaScript alone. Just those two, if you just leave those two alone, that's it. It's not ready for deployment within a business environment. But I will say Chrome's beefing up everything. Everything. I just got an update today on an application I use because I still go back kind of testing Chrome on everything I use. And I noticed today the application I use will not use anything but IE. Now it uses Chrome because Chrome now has the security components needed to run that application, that Windows application or that web-based application. And so you'll see a lot of that now today. Chrome's built, I would say, I wouldn't be surprised in the next year, Chrome's beginning to sneak into businesses. So